Good morning. Right now, I would like to give you a revision on the Lecture 1 Introduction part. Basically, this chapter is quite easy. All we need to know is about, let's say, the unit conversion, SI unit, and also significant figure as well as decimal place. So, the first thing is, for the revision part, you must take care of all those decimal place as well as the significant figure. So for those that is involve those operations that involve multiplication as well as division, then we use it is referred to the significant figure, and this significant figure basically based on the smallest number of the significant figure. For example, if there is a case that we ask you to find out what is the velocity of a car, where we know that V equal to D over T. So let's say the D is 10.0 meter divided by the time is only 5 seconds. Let's say. So for this one, the first thing is to see, and here is 3 significant figures, and here is only 2 significant figures. As a result, we try to get this one, the smallest significant figure, which is 2 significant figures. And hence, the answer is 2.0. And as to the unit, basically it's very simple. Meter per second, we put it meter per second. That is the final answer. And I would like to remind you all again, for this kind of question, you must try to maintain the number of significant figures, and the maximum that we can allow is plus 1 more, which means that somehow if you put 2.00 meter per second, it is still acceptable. But if more than that, normally we will say that it is wrong in terms of physics, all those rules. And for the second part, which is addition and subtraction. So for this one, we try to calculate based on the number of decimal place. And example is, let's say, if there is a vector in terms of magnitude is A equal to B plus C. Let's say we form this formula A equal to B plus C. Then we can say that, for example, the question says B equal to 3.07. Let's say it's meter. And C is 4.2 meter. By right, A equal to B plus C, this is an addition. And for addition, we follow smallest number of decimal place. For this case is 1, for this case is 2, so we choose 1. So as a result, for number A, the value of A is 7.2 meter, or it depends. In order to get it again, as I said, you can always extend 1 more, so you can put it as 7.23 meter. This is also acceptable and which is more accurate. But then somehow, as I said, the ideal case is to maintain the small scale, which is 1, but you can plus 1 if you think that the one gives you a better result. And for that, I would like to move to another part, which is conversion of unit. So basically, we study what is SI unit, and I think this one I don't need to repeat since that you already in SPM and should be quite familiar. And versus all those non-SI units. It can be metric unit, it can be some other unit, or the most important is you know how to convert it. A common mistake, let's say, in the rotational motion, we always say that, okay, the car is moving at 200 RPM. So this 200 RPM, definitely the RPM here belongs to non-SI unit. And we need to convert to SI unit in order to let us to do or to complete all those rotational motion related equations. Let's say 200 revolution per 1 minute. That is the meaning, so-called RPM, revolution per minute. So we can convert it, and you know that 1 revolution means 1 cycle. So 1 cycle, it occupied 2 pi radian. So it's 200 times 2 pi radian. On the other hand, 1 minute, 60 seconds. So 60 seconds. And hence, you can get it. So 0 cancel 0, so it's 40 pi per 6 radian per second. Of course, you can get the final answer in the decimal case and put it radian per second. This one we name it conversion of unit. So in order to convert the unit from the non-SI to SI unit, first maintain the number at here. Second, see which unit right now, what are the units given in the question, and we'll convert it accordingly. And for example, RPM is a common question. And in order to have a better idea, to let you have the better idea, we try to take a look on the all those, even though we say it's SI unit, let's say, we try to form it into the scientific notation. For example, if it's 3,000 kilometer, then it's better you put it as 3.000 times 10 to the power of 3 kilometer, which is also 3.000 times 10 to the power of 6 meter. That would be better. That is because, as I say, most of the equations or formula are calculated through SI unit. So, if you do not consider the SI unit, somehow you may get wrong. Although km here is considered part of SI unit, but somehow you need to consider this one. So let's say I give you a simple example: 500 km per hour. Let's say there's a one super fast speed car. It can run at 500 km per hour. So in order to use all those kinematic equations, you must try to think what is the converted unit in the SI unit, which is meter per second. So for this case, you can say it's 500 times 10 to the power of 3 meter per 1 hour. And 500 times 10 to the power of 3 meter per 1 hour. 1 hour stands for 3,600 seconds. So it's 500 times 10 to the power of 3 meter divided by 60 times 60, which is 3,600, and you get it, what's that? Meter per second. So the unit conversion or conversion of unit is very important as a fundamental in physics studies. Okay. And before I move further, I would like to give you a briefing of revision on the number of significant figure, which is student a lot of time make a mistake. So number of significant figure. So number of significant figure. First, if I say 1.01, by right, most of you know which is 3 significant figure. Okay, but somehow student may ignore this 0 and give 2 significant figure. And basically, just to let you know, if there's a number here, this 0 should be considered as well. So 3 significant figure is correct, 2 significant figure wrong. On the other hand, let's say the next example, 3.20. 3.20. For this case, although 0 is here, but we still need to consider it. So answer is 3 significant figure for this case. And 204. 204. So again, the 0 is in between 2 numbers, so it's still the same thing, 3 significant figure. And if I put it 1000, 1000. So this case is quite ambiguous, which that's why somehow I also discourage you to put in such format, because it can indicate either 2 or 3 or 4 or even 1 significant figure. Okay, so technically, which means that if you put in the scientific notation format, it can be either 1 times 10 to the power 3, 1.0 times 10 to the power 3, 1.00 times 10 to the power 3, and the last one, which is 1.000 times 10 to the power 3. So that means it can either 1, 2, 3, or 4 significant figure. And hence, I will encourage you try to put it in such format rather than this ambiguous format for the number of significant figure. And this one is very helpful for you to answer all the questions, so that you can set what is the maximum significant figure, what is the minimum significant figure. So, on the other hand, before we move further, again, there is another thing that we need to consider, which is decimal place. But somehow, as I introduced just now, decimal place basically is more for plus and minus. And in general, if we try to think about a complicated formula or something like that, you can see that most of the time, it involves addition, subtraction, multiplication, and even some function. So, it depends. Somehow, a complicated question, normally it requires you to find out the minimum number of significant figures. So that if possible, in general, maybe we can put it to 2 or 3 significant figures. But of course, that one depends on the case. So for lecture 1, basically the introduction is very simple. All you need to do is you must know what is the number of significant figure. You must know how to calculate it, and unit of conversion. Unit conversion should be the most important part. Thank you.